Hi everyone, this is Seba, and this is my submission to the band Theory Labs Ziki Hackathon. So, what I built is agent Minima, which is basically a zero knowledge disclosure agent. So, I'll start by explaining what I've built. So, this is the landing page, and I ran into major issues while building this product. So, first off, I would like to say that the LMM that I used, which is powered by BTL, the DeepSeek Chat V3 call, is genuine, and the process of generating a ZK2 is real. Like I've said here, the my settlement layer, which is base layer 2, is real. My session keys have been created through the ERC4337 has been real. But apparently I had to demo. I had to create like a data storage, a user data storage. I had to create like a profile, which is where the data would come from, which has been simulated right here. Because if this was like a real application, we would have to have like a source, which is will be provided by external provided by external sources and stuff. So basically, the pipeline is completely real. We have live LMM calls. We have real ZK proof. We have real on-chain transaction as well. But apparently, some part of my integration had to be mocked. So I'll just quickly run you through how to use the application. So you're going to quickly launch an app. You have to connect a wallet as well. We use MetaMask, and then we moved over to the main dashboard. So yeah, on my left hand side you can see the permission slip, which basically tells one function from another, right? This is enforced by the EVM, and you can basically check any action against it. So we're going to just run a bit of pre-pounded messages to the AI. So we have the legitimate section and then the overbroad section. So like I said, we had a demo profile stated, and I'm just going to go ahead and run this, which is going to basically check if this user can access our DAO governance, and then we need to verify if the user is over 18 or not. So this is our data storage as usual, and then we can see that the age has passed, the token balance is over 100, and then we have accepted this user request. So initially, like I was trying to explain earlier, we would obviously have like a DAO plugin, probably a set of pre-pounded requests or requirements that the KYC provider would have to have. But apparently we do not have any sort of real data to use, so I had to mock it, which is what we're currently using. So we can see that it has gone ahead to generate our proof, which will then we'll be able to access through this place. So I'm going to go ahead and do that right here, and then now we can see the transaction. So I'll go ahead and walk you through how it works, right? So apparently we can see that this was sent from the transaction was originated from this address, which is not human at all. This is basically from our agent. The user never even made any transaction, to be honest. So I can show you that from my wallet right here. You can see that it's different. So we can see that this is from our agent, and then we can see that everything basically went through. We can see the price about 0.2 cents, I guess. So we're going to click more. You can also see the data. I would have loved to decode all of this and explain how it works, but we can see that this was called with the execute proof function. we takes in like a target and stuff. So we're going to go to the labs. I think I should talk about the logs a bit. So this is a bit technical. I don't want to go into all of this, to be honest, but we can see how the state has increased. You can see that there was a change in these values as well. So we're just going to quickly see if we can verify the contract link. Okay, I think I opened this already. Okay, yeah, so you can see a bunch of calls that has been made to this address. So So yeah, we can say that every piece is basically independently verifiable down through from our section keys to the proof and the action, like, right, it's just basically on the ledger and stuff. So I could just quickly test the overbrush section, which is going to require more than just the basic things for a KYC. So we can see that our agent was able to tell this the excess requirement from our user. So we can see that this has been rejected, and then it propounded a counter offer, which I'm also going to just click, which is just going to basically ask our user to ensure that our user age is over 18 and token balance is still greater than or equal to 500. So we're going to do that, and then we can see that our agent was able to reason and figure out that this had nothing to do with just basic governance access. It was more than what was required, so it was able to read it, understand it, and then propound a better solution to it. So we can see that this is also a different transaction hash that has been created. And yeah, so just in case you're thinking, right, you can see that the reasoning part is genuine, which was the main point of this hackathon, DBTL, and it interpreted the request in context, and he actually got the point. And this is just what basically makes our agent trustworthy. It enforces the scope regardless of what the AI decides and stuff. So yeah, I don't think the agents cannot be tricked. Basically, it's the session keys is the real enforcement layer that we have created. So yeah, thank you so much for watching.